Hello guys, welcome to our next video of the playlist Google Earth Engine for the beginners. So in today's video, we will learn how we can calculate the normalized burn ratio, NBR for short. Let us look at through what is NBR first. So it's a remote sensing technique which is primarily used to identify the burned areas and assess the severity of the fire. So this technique mainly uses the two band near infrared as well as the shortwave near infrared band from the satellite imagery, such as the Landsat or the Sentinel, and using the formula such as like this net burn ratio is equal to uh, uh, near infrared minus short-wave near infrared and divided by their addition will give you the net burn ratio. So how to interpret the value and what is its range, how to interpret its range and what is the severity of the burn, we can see through the map, and what will be the output we'll look into in this tutorial. So let us start. First we will import our Sentinel data, which is of 10-meter resolution. So let's search in the data catalog Sentinel. So I am importing the Sentinel to multispectral instrument level 2A satellite data and rename it as S2. And let us create one region of interest, coming to our India, and zoom into any forest area of your interest. So I am particularly zooming into our Uttar Kannada district in the Karnataka state, and you can switch to satellite mode here and remove the labels if you want. And with the use of draw a rectangle, I am creating, yeah, I'm creating a region of interest. Okay, so rename it as ROI, which stands for region of interest, and uncheck our geometry. Now let us filter our satellite image by creating an variable image is equal to select our Sentinel data S2 and filter it by boundary first by using the function filter bounds to ROI, and filter to date. Let us filter to the latest date of 2024 1 1, and till, let us use till May. So 2024 5:30. Okay, also let us filter the cloud cover through the function filter metadata, and open our satellite data now. Go to the image properties and copy the cloud pixel percent, which we have to filter now. So give the argument cloud pixel percent, it should be less than, say, 1%. Okay, then select the median of those images which are present in between these filters, that is this boundary and this filter date, and clip to our region of interest. Okay, so let's add our satellite data to the map to see whether it is clipped or not. Give run. So the layer is loading now. Yeah, so satellite image has been loaded. It's looking blank because I didn't give any band combination, so it is not important to us now. So now let us calculate the normalized burn ratio by creating another variable NBR is equal to uh, select the image which we have filtered earlier, and use the function normalized difference. Okay, open the brackets, open the square brackets to pass the bands in list, and go to our satellite image again. So here you can see, as I have already told you, the formula is the normalized difference ratio between the near infrared and the short wave infrared. So let us search for our near infrared band. So you can see it is in the B8, and our short wave infrared is B11. So just select these two bands and add our NBR to the map now. So map.add layer NBR, and today we'll give the visualization parameters. The minimum value should be -1, and the maximum value should be +1, because the range of normalized burn ratio varies from -1 to +1, where the -1 indicates where the values which are nearer to negative or the -1 indicate that these vegetations are more severe to burning or they have already burned, and with the values which are negative, which are near to the positive values, are healthy, as well as they are less severe to burning. So that is the interpretation for our normalized burn ratio, and you can also give the palette color. Let's give red for the most severe burning scenarios, and white for neutral, and green for normal. And we can also rename our NBR layer as capital NBR to be displayed in our map layer. Okay, now let's give run. So yeah, here you can see some of the red spots which are, so the negative values also indicate the bare ground which may not be vegetated. So let us stretch our NBR to see what's the range. So you can see the value ranges from -0.2 to 0.4. You can apply now. So yeah, now you can see all the regions which are in the red color indicate the vegetations are more severe to fire risk, and which are in the green indicate they are healthy, and they are of less severity to the burning. So the more speciality of the near infrared and the short wave infrared are that they are more sensitive to the moisture which are present in the vegetation as well as the soil. So based on that, the index is calculated and they are visualized. So that's it for today, guys. If you have any kind of queries, you can post in the comment section. Thank you for watching.